Okay, guys, we're on. Okay, let's go back to the thing.
Bricks!
Good way to start. Chapter 4, right?
Ja, man. Start off from the beginning.
Okay.
Okay, so from the beginning. No. Reshit. From your design, the currently. So you're not doing night anymore.
Okay, so here we go.
1 week?
State affects behavior, behavior affects state. There's instance variables and there's methods. Okay? Instance variables affect what the methods do. Okay, like we have in this example. Let's go to our example over here. That if the size, which is an instance variable, is over 60, it goes woof woof, otherwise there's rough rough, otherwise yip yip. So we see that the instance variables, whatever the state is, affects the behavior. Okay, then we talked about how every single object has the same method. So the method can do different things based on the state. Okay, then we talked about the parameters.
Like this right here, this little circle right here.
This thing over here?
Yeah, so that thing, when I went inside my book and I was trying to figure out how to put it together, I was confused on that because of what you wrote. I used you as a reference and I just didn't see how I can use that in this situation. Do I put the void bark in the class or I put it in the class with the main? Put in the class...
Bark, think about it, what is bark?
Bark is a method.
Method of what? What barks?
Bark.
The dog barks. The
There we go. So then you know automatically it's under the dog object. Remember, and that's when you're thinking of when we're thinking of programming for Java, we have to get out of the SQL mode and remember that we're doing
The
object.
one that has the main in it is just the action.
Main just plays around with the
It itself is like a remote, no?
in a certain sense, but it's gonna get me more confused.
Okay.
But it just end of the day, main will just start running the program. That's
Right.
that's what it's used for. But if bark itself is a method that belongs to something, belongs to a dog. So you know right off the bat that bark belongs to the dog.
Void has to be belong to a class, yeah?
Can who?
Void need to be belong to a
Void
class.
just means it doesn't return anything.
No, the void bark.
That belongs to a class,
Yeah,
yeah.
it has
A dog barks, right? A main doesn't bark.
okay.
A dog barks. That's the thing in object-oriented programming. An object has state, in other words, it has instant variables. What does it have, and what does it do? Okay, so we see over here. This over here, number of barks, what's that called?
Number of barks,
What is this?
like how many times we can say the dog will bark.
Yeah, what is it?
That's,
What
a, that's
it's,
a instant variable?
No.
No, that can't. That's a
Local. It's a local variable, no?
Okay, it is a local variable, that's true. But besides that,
It has
what,
internet, but I'm saying
What?
it's not
it
that.
is local variable, but what type of local variable is it?
Int.
It's a parameter.
Parameter, there you go.
Why? What does it mean?
Parameter is what you pass into a method.
Right. There's an argument and there's
I need a
parameter.
pencil. Do you have a pencil?
Okay, so what's this? 3.
Like, how do I know that's parameter? Like, how do I know where it's parameter and where it's not?
Well, you have bark, which is the method, and in here you have parentheses of what you're passing into it. That's a parameter. What's this 3?
The 3 is the number of times it barks.
Yes, but what is it? What is it representative? Without telling the person what it does, what is it?
Argument?
There you go. It's an argument. Right? So argument is what you pass into the parameter.
Honestly. Okay.
Okay?
The teacher there, they told in the book, I think you can keep reading that. Tell you that argument about also the parameter
Yeah.
in the system chapter.
Yeah. Argument is what you pass into it. Parameter is just what actually you write inside the method.
Okay.
Okay? Methods return values, right? So over here, what's this method returning?
It's a good pencil. It's a good
What's this method returning?
That's returning the
the part.
Nothing. Void means it doesn't return anything.
Okay.
Okay? What is this method returning?
that is all returning everything that is inside the size.
This one doesn't return either. Void doesn't return anything either.
Oh, I thought I was looking at differently. I'm sorry.
This
I meant
one.
to say that right. Obviously, yeah. Okay.
Yeah.
The one that says return is probably returning.
Yeah. So you'll notice when
Three
something
times.
when something's returning something, it says return, and this integer must match what you're returning. If you say you're going to return an integer, you better return an integer. So size better be an
size
integer.
has to be.
Okay.
So what's the whole entire point of void? Why have it there if it doesn't return anything?
Why does not? Ignore it. It's a good question for Java. Why you have to put it there? I don't know. It's just basically telling you that you don't have to. That nothing's going back. But why should? Yeah, it should be. It should be. It should be there without using it at all. It's a good question.
I know you gotta use it sometimes.
Yeah.
So when
but
you're
it's
using, what
never
do you
got
mean when
that
you're
yet.
using have to be integer? What did you talk about?
So let's look over here. So here's int. Gives secret. So this gives secret method returns an integer.
Okay.
So it returns 42, right? 42 is an integer.
Okay.
Over here, we have a variable that's taking in that secret,
Okay.
and that must be an integer as well. Okay. Next thing, methods can have multiple parameters. Okay, so you just make a list, separate a list by commas. That's it.
Hmm.
Okay. We'll see examples later on, but it's the same exact thing as everything else.
In Z and in Z and Y. So
Yeah. Yeah. Okay. Okay, so now let's talk about this one. This one, yeah, look at this one over here. Java is pass by value. This means pass by copy. Okay? So what is it? What happens over here? Let's go to the whiteboard for a second. Okay. I think this is where we got up to yesterday, so.
What?
This is I think where we got up to yesterday. Okay, so say we have over here, it's int, and it's called bark. Okay, and this bark takes an integer, and we'll call it x. Okay. Okay, and what does it do? Let's just leave it without. This is just pseudocode. Okay, what this one does is it says whatever it does. Let's say it barks X amount of times. Okay, so like looking at this code, let's just copy it here. It's a simple one. Here you go. Let's look at this one over here for a second. Ready? Okay. Okay, so I have over here. Okay, so you have over here this method doesn't return anything, but it takes a parameter called num of barks, and depending how many times it has in there, it barks how many times. But 5 will bark 5 times. Or say rough 5 times, right? Okay. So what if we have a variable over here? Let's go to the thing.
So
We're in a thing, and we go x equals 5 times, right? 5. Okay. And then we go ahead and call. So we have this dog object. So we have dog, and we do dot bark, so we can make it bark, and we pass in x. Right? Well, 5 times, right? So what happens over here, right? It uses this thing, and over here it's keep on dropping it down, right? 5, 4, 3, 2, 1, right? It's actually changing what you pass into it, right? It's not going to be changing this one, because it's not passing x itself, it's passing 5.
if I put x equals 5 on top of void bark,
Yeah. So
Where are you
If I
putting
put
this?
x equals 5, that wouldn't make a difference. Because
Where did you
number
put
of
it?
bars. If number of bars
this is in
equals-
the main. Say you have a main code, in your main class. You call it. You create a dog, and then you make it bark 5 times.
Right.
This x, even after you run this code, x won't be 0, even though over here number of barks drops down.
Oh,
It'll
just
still
the
say
5
5.
inside the X.
Right. 5x. So if I do dog.bark, right?
Yeah,
And
the
after
5.
I go whatever, print out whatever the value of x is, x will still be 5. This thing's not working good, by the way, Andy. It's not working good. Okay?
Okay, so it's not changed. Okay, only the X.
The x
inside
will be
the bar.
5 even after.
Yes, that's the main point.
So
So
after do num barks and it equals -1 each time it goes around the
right. So number of barks just grabs the value of what was in x, not x itself. X doesn't become number of barks.
Okay.
Then afterwards, if I print out an x, x would be 0. Because it keeps on changing it over here.
Yeah, but what if I don't?
What?
If I just did this whole other situation where I put the x on top of 5 in front of the void bark and instead of
Void bark is this is in the class.
well, okay, fine. So if I
This
did,
is a totally separate thing. This is what we actually call it, like in the main
if
method.
I'm calling x equals 5, I have dog bark
Right.
equals with x would be basically dog bark
5 times.
Then
Right.
I'll put that in a while statement or in a while statement after.
Why else statement?
If I wanted to change it so that it would bark less times each time, that wouldn't change the x. Intermission.
Delta.
This will bark 5 times. It's going to do a loop that's in here anyways.
X equals 5. We
Right.
got that. So dog.bark equals 5.
And now we'll bark
Now,
5
if I
times.
did a while statement
To do what?
to make it go down, just go to loop. So now the x becomes 4, then 3, then 2,
But
then
it's
1.
already in loop.
So if it becomes 3, then 2, then 1, right?
Right.
And now I'm finished. Okay, I finished the while statement. Is x still 5?
I'm really not so sure. You talking about like after a while over here, or a while before the dog that bark in?
Before the dog.
Then it will change. Yeah. Because it's
And
in.
then at the end of the statement, after the whole thing, x, if I went to go, x would not equal 5.
The point. Yeah. That you can change x over here. The point is
I
that
thought you were trying to say the x always stays 5.
no x when you pass it into here, no, even over here it seems like it's changing it. It's not changing it. It's changing. It only passes in 5. So this becomes 5, but this stays. X stays what it is. Okay.
Maybe I don't get it.
Yeah. I'll watch this. Okay. If I go over here, right? You know.
That situation, I guess, I don't. When you're bringing x equals 5 is that I don't. When I get
This is okay. So this is a separate class. This is a tester class.
Yeah.
We create a dog, and then we do like this. Ready? Dog. Oops. This is really not working good, Mandy. I think I'm gonna turn this.
Dog stuff. And then you like dog? You like dog? Like dog. You like dog stuff. One.
that's why I get that.
Okay. X equals 5. What's gonna happen now?
Right now, dog.bark.
What will happen on your screen? Perfect. And this number of barks, right? If I were to print out number of barks also on the screen, you would see 5 bark, 4 bark, 3 bark, 2 bark, 1 bark.
Right.
Right? Now if I go ahead and print to the screen, print out X, what will X be? 5.
I didn't know you could do that. Oh, afterwards, after all did my system train.
Yeah.
System wrote down x. It's still equal 5.
We still do
If
5.
you're doing print dog barks, print the number of barks, how you print the number of barks?
Oh, yeah, your system line prints in here. Put the system
Yeah,
line.
but how you doing that in the other object? In the
That's what you're talking about. This bark calls the bark method.
Yes.
In here, I can add another output line over here. Right over here, it says rough. I can do plus in there and do, number of barks.
So when you run it, the dog with that bark, when
Yeah.
you run it, you're gonna see rough
Yeah,
5 times.
yeah.
You don't have to have print.
No, just
Oh.
calling it in here.
Okay.
Right? Okay, so the point is it passes the value, not this itself. X stays the same. Okay? However, this is where later on we're going to talk about this, how this you have to be careful. What happens if you pass in the object reference? Now this is a primitive value, a variable, right? What if you pass the object reference? It actually passes in the remote control.
How to do that?
Well, this is not an example, it's not passing that, but say you pass in a, let's give an example, say you have a method here, say you have, Here you want to give an example. Okay, say you have one where you pass a guy a gun to shoot, right? So you have a method that grabs a gun and shoots it. When you pass the gun, even though it's passing the value, remember that value is a remote control. So you're giving him another remote control that points to the same gun. So whatever he change he does, if he breaks the gun inside the method, your reference over there is also going to be a broken gun.
Is there a way to prevent that?
Later on, we'll learn more about it. But in general, it's the way you want it to work. Usually when you pass an object, you're expecting it to come back different.
Yeah.
Okay?
So, okay.
Okay, so when you pass, right now we're learning about these type of ones, but if you look at an actual object, this chapter's not going to talk about it. Later on, I'm going to go more in depth.
My upper value is done.
Okay, any questions on that? All good?
Yeah.
Okay, let's go back to the screen. Okay, so remember return. Oh, we did that already. Okay, so that's what it means as a pass by copy. You're just copying whatever was in there. You're not taking it itself. Okay, so we have over here, let's look at the example. So over here, we're returning 42. What if you want to return many things?
So, hold on a second. Turn the number 42.
This give secret, if you call the give secret, we'll get back 42. Right?
Okay. 42, you put already in, you're stating that gives the secret is
This is a stupid example. It's always 42. I mean, obviously you should make a better example. The point is that it gives back 42. What if you want to give back 42 and 50 and 30?
So you're doing reference, no?
Then can you just put 3? Right? Is secret like secret 3? No, you have to use.
So there could only be one return. Returns once and that's it. The only way to return many things is to put it into an array. Remember before we made an array, so we make an array and you pass back an array.
You have to make array last time.
So we over here, array is going back, and over here you give back the array.
So you write array before give secret and return you write the array.
Yeah,
again?
we'll learn about it later on. More better, examples.
Oh, okay.
Okay, no, that arrays that we have done before. Say we had, int, and we made it with. Wow, it's really not working good. I can't return this. Int 5, right? So you had five buckets with int. That's cool and dandy. What if you want to return a dog, a pig, a cow, and many things? So say you have a method that passes you back, like, say you have a game that's buying like a farm, so it passes you back a farm, and the farm you have all these different objects. How do you pass by many things in one array? So later on, we're going to think.
You're in your transfer mode.
What? But usually an integer is just integers. You can't have a thing that's holding a dog in one
So
thing.
why can't we do the same exact thing with the index and the other one, where we just connect it from index to string? What we did in the other one, we used reference.
I remember the example. What was the example?
The example we spoke about yesterday, where we had to under test arrays. So under test arrays, where it was it equal here.
Okay, remember that one. Yeah.
You remember that one? So why can't you just do it like that?
Well, we'll see later on. There's actually an easier way. There's a thing called an array list. Later on, we'll learn about it. Array list, you can put many different types of things in one array. So the first bucket can hold a dog. Second bucket can hold an integer. What? Yeah, that's what it is. Yeah.
What is array?
That's what it means. List. Okay.
Wide variety.
Okay. One more thing. Okay. Another thing. Say you have a something that returns something. So like the get size, right? Let's go over here, for example. See the code over here? Get size returns the size.
Yes.
You don't actually have to make a when you call it, you don't actually have to put it into anything. So, for example, say I'm going down here, and I need to get, it's a different code. I do like, x equals, this dog I made, so doggy dot get size, right? Right? And it's an integer, right? So I go like this, right? Int x equals dog dot get size, right? I don't actually have to do that. I can just do it like this, whatever it is, and use the code as is. You don't have to put it anywhere. Even though it's returning something, Java lets you not use it. And like chuck it out. You know what I mean? Whatever it is. Say the method does something and gives you back something. You can just do the method and don't worry what it gives back. It just goes to the garbage. Okay. I get a very famous example of this are like here's an example. Say you want to make a database connection. So many times you'll put a database connection in, and it will turn back something to you that says, okay, you're connected to the database now, and it gives you back success, right? So say you don't care about what it gives back, you just want to make the data connection and continue your code. So you don't actually have to have a bucket holding that, right? You just say, do what you gotta do and continue. I don't care about any messages. Don't give me anything back. Okay? So for example, say you had one that was like this. It was called doggy, I don't know what it is, say doggy jump. And it would turn back to you how high it jumped. You don't need to care about that. If you want, you can pick it up and you can make a thing and pick it up. Or
do you want to know that it jumped? Or?
It's up to you. Sometimes you just want to do it. Do your jump. I don't care how high you're just go and jump. So it depends. It's up to you to decide whether you want to take back that thing or not. Okay. Okay, so over here you see we have anywhere we can use, and then we can use it like this. So this get size returns an integer. So instead of doing 3 plus 24, I can just do 3 plus get the size. And it returns whatever is there, and we can just plus against it. Okay, for example, over here, you see over here we're doing dog1 equals 1 get size. We're just sticking it right into the line itself. We're going to have to actually beforehand make a value for it and pick it up into the variable. Over here, 1 get size works fine because it returns something, right? It returns it back to whatever it's calling it. So over here, it'll print out the line, which can drop right over there. If we run this code, we'll get that.
Right.
70, 45, 8, because that was what's in there.
70, 45, 8?
If you don't want it, just don't put it in there.
So the rest of it will still show up there.
Yeah.
The rest of the rest.
Yeah. Okay, guys, here's the next big thing. So we've been talking about object-oriented programming now for a couple of weeks, but we haven't really gotten into the meat of it. This right now starts the first main thing of why people actually use object-oriented programming. Okay?
What?
This is, right now we're going to learn, there's 3 main reasons why you use object-oriented programming. Number 1 is right now we're learning encapsulation. Number 2 is inheritance, which I haven't talked about yet. Number 3 is polymorphism, which I haven't talked about yet either. But this is the first one that we're going to talk about. Okay? Encapsulation puts a force field around the instance variables, so nobody can set them to something inappropriate. For example, over here, the cat.height equals 0. That should not be allowed. You can't set your cat to be 0 inches high, right? Makes no sense at all. So we have to have a way to protect the instance variables that people can't touch them, and the only way to access them is through a method.
Wow.
That is called encapsulation. In other words, if a person wants to change the height of the cat, they can't just do the cat that height equals 0. They have to go to the cat set height, which is a method you define over here that only lets, you see, there's a condition in here. If height equals more than 9, then let him change the height. Otherwise, no.
Otherwise, you can just change it?
Right, you can't change it.
So there's like the security measures.
Yeah.
Where you can change it? From the class?
Anywhere. Outside the code. So anything that's calling that class, that object that you've done, can never change it because you made it private. Okay, so you see over here, here's an example. Here's a dog. Ignore this top of the screen. Just look over here on the bottom. Just look from here to here. Okay? We have a good dog. That's the name of the class. Has a size. We don't want people setting the size to 0. Right?
Okay.
So we have a set size. Over here, I'm letting them do it anyways. But I can put a condition over here, for example, like this condition, that says if, whatever we pass in over there is more than 9, then let him set it. Otherwise, don't. Here, let's go ahead and do that to this one. Ready? Set size int s. Okay, so let's do this right now.
So the s, what is the s? What do you mean the s?
That's a parameter. Remember?
Okay.
Here, I'm gonna make this easier for you. I'm gonna make it like this.
The bigger.
P size, so you know clearly that that's what's getting sent in.
So they're gonna change the other one now.
Huh?
You're gonna change the other one out to piece size?
Yeah, I am.
Oh, okay.
Okay, and what I'm going to do is I'm going to use this same thing that they did over here. Okay, so I'm going to go like that. See? If P size equals more than 9. Okay? You see? And let's put this all in. Okay, if it's more than 9, then go ahead and make the change. Otherwise, don't.
Oh.
If more than the size equals 2.
Otherwise, don't let it do it.
That's awesome.
Yeah. Now we'll see later on. There's more things we have to take care of. For example, what's it going to be if they don't set it? You have to give a default. We haven't learned about defaults
Just say
yet.
else.
What? There's an easier way. Later on, we'll talk about that. Okay.
Do a warning sign or something.
Okay. So you see over here, this he can't touch. No one can go and touch it because it's private. You see? This is the key thing to look at. It's private. The only thing he can do is set the size through this public method.
If I was hacking, I would have just had to change that private public.
One more time.
If I was hacking.
That's one way. Yeah.
Yeah, but how? Where you need to see it? Where you need to find it? Where you can find it, you can change it. Right? What is
Wait a minute. It's hacking thing.
No, the private right now. Okay.
Look,
If you
over
do the
here.
Code, you're gonna see
Okay.
this class.
Okay. Watch this. You see over here. So this is the tester. Here's good dog 1. Set size, right? I cannot over here, watch, I can't do this. I can't go 1 dot size. I can't do that because I'm not allowed to see size. Size is private.
Okay.
Watch, if I do this, look what happens. It's not going to work.
Wow, I just realized that.
Watch what's going to happen.
So you can change it.
Let's go ahead and compile this. Okay, you see? Size has private access in good dog. You cannot do that. See? In other words, it's preventing this test drive, from changing the size directly. You want to change it? Go and use the method. This is called encapsulation. We're protecting the instance variable, for protecting the state from people can't make things, sugary. Okay? Okay, so let's go to the end over here.
So you just can go. You just need to go to the good dog and change from private to public if you want. No?
Well, if you have access to do that. Usually, remember, code when you give to the client is compiled. They can't change the source anymore.
Right.
When people download an app from Android, it's not source code. It's compiled code, which is not readable and it's not touchable.
You just can see it. You just only can see it.
You can run it. You can't do anything with it. It's compiled. Remember, bytecode you can't really change. It's not human readable. It's not even, it's meant for machines.
Really?
Okay, so look now. Look over here. So you have 8, right? Remember, we put a thing over here. That what happens if I put an 8?
Screwed.
Get screwed. So look what happens. This will compile fine because it's not a compilation error. Okay, so what happened over here, you see? Dog 3 is 0. Even though I set him to 8, it doesn't work because I'm not letting him set it to 8.
So I would have, I don't want that. I don't want someone just to put it in thinking that it's able to go through this and as 0. What I want to do, I want it to come out as like error.
Yeah, so you can later on we'll learn about exceptions. You can cause an exception to come up.
Meaning an error?
An error or whatever you want. Can't do that, yeah. Use something else. Okay?
Okay.
Okay, so let's make this to 10. Okay, that's fine. So we got the basic gist. This right here, the idea of this being private and this being public, that is the idea of encapsulation. It is extremely important that you get this concept. This is the foundation, one of the most strongest parts about Java programming.
Right.
and object-oriented programming is that you're able to protect people from making crazy values in your states.
Which can cause bytes memory.
Well, it can cause things to be hacking a sugar game. I mean, what does it even mean a dog that's 0 inches tall? It makes no sense. You know what I mean? It makes things that work normally. Okay. Okay, so how do you do it? These are called access modifiers. See over here, the private, public, these are called access modifiers. So private means no one can see it from outside. Over here, I can reference it. See, this code itself can look at it. But over here, it has no idea that there's even such a thing called size. All it can do is do set size. Okay? And remember now, since it cannot see it, in order to get it back, we have to do get size, because it can't even look at it.
So if you're gonna,
It's like go behind the freaking closed doors. You know, when you want this, press this button. You can't see anything. Go behind it, press this button,
Right.
and we'll get it for you.
Yeah, get a few,
so
and we'll change it.
change the public void set size to private. It's also the same thing.
Won't run either. Yeah, you can't do that.
So Apple does all the program.
I mean, everyone does. This is also for programmers' sakes. I mean, for example, say one company I was working for, you know, if you don't make this good, another programmer is using your classes can make huge mistakes. But if you can never touch that size, you always have to go through the getters and setters, then you're pretty much safe. You can never do something that's just whack. It has to be.
Change the class.
Well, we don't have access to that.
Yeah, but
There's some other programmers where none of that.
Yeah.
after the code is compiled, you can see the code.
No.
So how do you know what is the variable that is inside? How do you know what's going on inside?
Compiled code is not for programmers. Compiled code is for the end user. You run your app on your Android. That's compiled code.
So how do you get the references then?
I'm not sure what you're talking about.
How do you connect the
Only
app?
another programmer gives you another program. If he wants to send you the program, he'll send you the program in a zip file and you open it up. But you can't take right.
I'm not trying to answer your question.
No, when you say, so what is give me the private, okay, you don't want people to see what's going on, okay?
The compiled code, that's a totally different story. You're mixing different things. This idea that you can't see it, that even other programmers,
Okay.
other code, any other code that's calling this, for example, I'll give you an example. Say you have your airplane code to go up and down, right? You have to be very careful about what any other code in the system does when it calls that. It can't do it too quickly, too slowly, or making the wings go up and down, right? So anywhere in the system, any other code that happens to call this wing thing of changing the wing motion has to go through those getters and setters. You can't change it just directly or change it, bring the wings up 90 degrees. No, you can't do that. Go through these setters and getters. Nothing else can ever get to touch it. That's what this does.
So if you want to go to a 90-degree angle as a plane, you want to go up 90 degrees, you have to stroke 10, then 20, then 30, then 40. You have to get it instead of making sure that you don't just go directly up there and you slowly go up.
In other words, this over here will make sure that never, it's impossible for the size that someone else, any other code in the system can change the size of the good dog to less than 9.
Yeah, but how do you know that one that set size is inside the good dog?
How do you know that this exists, you're saying?
Yeah. Yeah. How do you know that when you write the code?
That's the mistake. Later on we'll learn about that. We'll learn about that. That's
can change if you can see what's going on in good dog. How do you know that they have their set size?
okay. Later on we'll learn about this. We'll learn about more of how to look at source code and how to play around with it. Okay. So these are called getters and setters. Okay. So let's look over this example over here. We have electric guitars. Okay. Over here, what are these called?
Those are the state, yeah.
What's the other word for it?
These are variables.
Okay, what's this? Okay, so notice how for every single instance variable we have what?
Method.
How many methods?
As many as you want.
How many? Look.
36.
How many methods do we have per instance variable?
2.
Yeah.
You always?
At least these sets and gets. If you see for brand, get brand, set brand. Number of pickups, get number of pickups, set number of pickups. Rock star unit, get set.
But okay.
Okay?
So get is getting okay.
Getting and setting.
That is me the getting.
Okay? Here's the thing. general rule of thumb: make every single instance variable you ever create private, and then make getters and setters for them that are public. That's the rule.
What?
Repeat that, sorry.
Every instance variable you ever create, make it private, and then make a getter and setter that are public.
Oh.
I have the getter and setter. Why? What makes it different? What?
This we just discussed. This is encapsulation.
Go back to the code that you had. Short.
Okay.
You go back to the code.
Alright, got it.
So like they're private in size, and then you did after
Get size
that
and set
public
size.
and get size. So
Right? Just everyone in all your code you have for the rest of the book and the rest of your life, 99% of the time, so it's very rare you won't do this. 9% of the time, you want to make every single instance variable private. No one should ever be able to touch what you got directly. They want to touch it, go through the getters and setters. And this is really any object-oriented program. Okay? What's another cool thing about encapsulation? Besides the fact that it protects from crazy things.
What is that cool?
Another cool thing about it is as follows. Look at this. Say we have set p size equals 9. Right? Okay? So when a person does it, they go to be into set size. If later on we want to make a different rule in the system that not only it can't be more than 9, it has to be less than 100. I can just go into here and add the code. And no code will break because they're still calling set size.
Okay.
Right? In other words, I can change the code inside here, and it's fine because they're just calling set size.
And you're fixing set size.
Yeah, but it's the same thing. It returns the integer. I do more things inside of here, but from their perspective, their code, they just use the same code.
The user perspective.
All right, because they don't have to redo any of their stuff.
Right.
Still the same. Wow.
So you see, so say for example we have a one that's called get database connection.
Well, this is an update, pretty much. When
But all
Windows
you
is updating your stuff, this is the
That's
update.
something
They're
to do.
updating stuff like this, where everything's the same. You still click start, but they update.
100%. Yeah, same idea.
So basically,
How would I write that though? Like p size lower than 9, and then slash.
And yeah, not slash. Slash
Yeah,
is
and-
or and then yeah.
So basically, the good dog is you basically build a blueprint that is safe and that no one can touch it. And if they want to play with it, you just need to do it.
They gotta go through the methods.
Text.
Yeah. So in other words, the point of it is that the only thing other codes have access to is methods. Instance variables should never be touched directly. That's basically the end of the story. Only thing a person can ever go is go through methods.
Method.
A method. No other code in your system is able to go to your variables directly, instance variables. Okay? Okay. We're almost done with this chapter. Okay, next important point is that instance variables...
get the code only through the method. What you said about the method? Forget about it.
Yeah, only through methods. You can never touch the instance variables directly. Okay, next important thing. Let's look over here. Let's make this one 8.
1 second.
Okay, so look over here. Why is it? You see, it says dog3 is 0. Why is dog3 0? I made over here. I set it to 8.
Where?
Because you didn't control.
No, the 9.
That's
P size is 9.
What?
P size is 9.
In other words, it has to be more than 9.
Yeah.
Okay, so then why is it 0?
Because it basically failed.
So what?
Since it cannot return anything, it goes automatically to 0.
So what's 0?
Default.
There we go.
Null. Not null. Not null. Null is a value. Default is 0.
Okay, so integers, so instance variables will always have a default. Even if you don't set it, it will have a default. Like you see over here, it tried changing it to 8, and it didn't, it stayed 0. So here's the rule.
Can you change that? Is that going to say 0?
Here's the rule. Integers will be 0 by default. Floating numbers, like decimal, stuff like that, will be 0.0.
Oh.
Booleans will always be false,
Okay.
unless you change it. And references will be null unless you change it. No,
In that case, it would be false. What if I wrote true? Then it would be true.
and change it.
Right.
But by default, when you have an instance variable, say you have a variable that's called, has gun. Before you start changing it in the objects, it's null. It's false. By default, it's false.
That makes sense, right?
And an object reference, by default, is null. It's a remote control not pointing to anything. So you have, say, there's a human object, and it has, mother, right? So yeah, you can link up with the mother, but until you set who the mother is, it's a remote control that's not pointing to any mother.
But it's still a remote control.
Remote control, it's no.
If it's 0, then it would be.
No such thing by 0. Remember, objects don't have 0. Remember,
Right,
objects
saying, so
are just in remote control, either pointing or not pointing. Okay. Final thing, basically, of the chapter. So what's the difference? Here's one difference between an instance variable and a local variable. Remember, over here, this would be a local. This would be a local variable, right? Because it's in the parameter.
And the size is.
The size would be instance variable, right? Let's go over here, for example. Let's go into one of our other methods. Okay, you see this example? Int x, right? This is what?
X is local.
Okay, because it's not part of the class, right? It's used inside the method.
So if you put it up above the public,
then it's part of the class. But as of now, since it's inside the method itself, it's just a local variable, right? The method uses it and drops it to the
Like
variable.
anything inside of curly braces.
This also is under curly braces.
No, inside the
Method.
Yeah, method's curly braces.
Yeah.
okay, if you put above the public.
Remember, it's not that simple, because over here, size is also used in between there. But size is a reference to the instance variable.
Well, so I can't. Right. Okay.
Okay, in other words, it's something that you declare. In other words, I'm over here making it integer x. I'm declaring it over here.
Mhm.
This is the local variable. So what's one of the differences?
Oh, okay.
One of the difference is as follows.
You can change any local. You can't change any variable.
Well,
You can change any local variable.
you change both of them, but over here you have to provide a default. There is no default for local variables. So for example,
What would you do as default?
well, watch. Okay, here's a stupid little thing, right? This is called foo. You see this? All foo does is does x plus 3. That's what it does, right? So watch this.
Watch.
It compiles now.
How does it compile? No, you don't have the class. You're not stating the class, are you?
Yeah, look, class foo.
Oh.
Okay, but watch this. If I do x just like this, it won't work, because a local variable has to be assigned something before it's used. Because I'm using it over here, so I cannot just create it and then use it later. There's no default.
But then if you had the what's it called? Then if you had the
You see? You can't use it.
Then if you had let's say it wasn't a local variable and you had the method in a different class.
Say it again. What if what?
If you had the method in a different class that goes integer, basically integer z equals x plus 3, and you had another class saying that x, integer x, you're just stating.
The question is, what is x? Is x an instance variable or a local variable?
X in this case would be an instance variable.
Then it has a default.
So then if you did.
Then it's 0.
Okay.
But if it's not an instance variable, it's a local variable.
No, I know. I'm just
Can
thinking because
instant
if you
variable,
Yeah, you're right.
Can instant variable be same or also both local and
No.
instant? Like if you put an int x above the
Yeah.
public. you
And then
can-
again over here, you're saying.
Yeah, you get it there.
Don't do it because it's going to confuse you. But we're going to learn about later on, like which one does it use. But no, it can never be both. The question is, which one is it going to use now as a reference? Okay, but this over here won't work. It doesn't compile because there's no such thing as defaults for local variables. Okay. Okay. This is the last thing, and then we're done. Gee, it wasn't that hard, chapter 4. Last thing is, how do you compare? So you want to compare x to y. Is it greater, smaller, is it equal? Right. So equal is how you compare things.
Well, I thought that's how it is.
What?
That's how you say it equal. How do you compare?
That's how you compare two things. If you
I
do
say-
one, that's how you assign something. For example,
Right, that I know.
so like over here, C equals A, we're assigning it. A equals 3, we're assigning it. Over here, we're comparing it. If A equals B, then do something.
Oh, okay, fine. Yeah. Well, that's what I'm saying. But we say is equal to has a
Yeah.
But before we never used the word equal. They have a good, yeah.
Right, so this is comparison. Okay, so we notice over here, compare, you just use two of these. Okay?
Otherwise, in other situations where we say, if you know a equals when a equals 1, then x y z would happen.
One more time?
If a equals sign equals 1, or if
So it's the same thing. You're doing the same thing.
right, but what did we name it before? We didn't say it was. What did we use it before? What was the name we used?
Yeah, I remember. But yeah, it's the same
It
thing.
has the equivalent of it.
Yes, it's the same thing, yeah. Okay, so notice now, it says comparing what's inside them, right? So you have an integer x, integer y, they both hold 3, fine, they're good. What happens if it's an object?
What?
What happens if it's an object? If I do this here over here, foo a equals foo b equals a new foo, and then c equals a. Okay, so does a equal b?
You never know.
Doesn't. I mean, you never know.
No.
Doesn't. A is its own separate object out there.
Right.
Okay.
Does a equal c?
Practically, yes.
Yeah, because it was done. Right? In other words, over here, equals by objects means do they point, do the remote controls or point to the same object? That's what it means, equal. Okay?
So if A equals B, it's not good.
Because they don't point to the same. Imagine two remotes. Either pointing to the
Yeah.
same dog or not.
Okay.
Only A and C you point to the same dog. That's why it's equal to the same. Okay? But what happens? Say you have, let's give it that. Say you have a string. Okay? Remember, strings are objects. They're not primitive variables. They're objects out there. So you have a string says Mendel and another string that you created called Mendel. And you do equal. They won't equal. Because they're not the same object.
If you're doing string A and string A, would that gonna be equal?
They won't be equal. So how do you check if they're equal? Even though you know they are equal. So you have to do this thing dot equals. We'll learn about that later on. But that's how you compare.
Built in that.
Yeah. That's how you compare objects. We'll learn how to use it later on.
This is next.
What do you mean? If you know A is A, all right, and you know it equals A.
Here, look. Let's look at the whiteboard. Say you have over here.
You want a big one? Why am I getting a big one? Big one.
Okay, so say we have over here. Say we have string. Why is this thing not working, man?
Like
String. What do I want to call it? X equals new.
Very good.
Yeah, it's not working at all.
This is why when you buy stuff from Office Depot,
I'm gonna return it.
Office Mart.
Okay. Same thing. String. Dang. Y. Equals new string. Why is this thing not working, man?
I have no
Piece of.
Keep asking and maybe he's gonna know. Keep asking, maybe he knows.
We're playing around with it, so we
That's
can-
very, very
Okay.
good.
So these two things. So now we do X, whatever it is. Say this might be not even the right code for it. I haven't done this in a while. For strings. But say do. Man, this thing really sucks. String S equals equals S, and Y equals S. Okay, forget it. I give up this thing. What's wrong with it, man? What is wrong, man?
Maybe you need to sharpen.
We're done anyways now, so I'll finish it up and we'll beat you after tonight. Okay? So does X equal Y? Equals, right? Two equal signs. Does it equal Y? Yes or no?
X equal Y, no.
It doesn't, because even though they both equal S, they're objects. So they're not pointing to the same remote.
Mm-hmm.
So how you do it? Later I will learn there's a thing called, say, X equals,
dot,
We got you.
and there you put Y.
which will say
Oh.
It'll say true or false. It'll turn true or false.
Okay. Right.
Okay, because then it actually compares more, more intelligently what's the object holding.
But is S one object?
It's not. Two different things. X is referring to one object out there that has S in there. Y is another object that has S in there. So you want to compare them. They're not the same. You just do equal because that's not pointing to the
Right,
same
so
one.
if I do X dot equals
Then
Y,
we'll find
then
what's
I'll
a
say,
holding.
okay, yes, they're both S.
They're
And
both
now
S.
But they're two separate. I had two different
Fine,
objects.
but you can know how to deal with it. Say for example,
What will it return me?
True.
Okay, let's say it's true. Then what?
I'll give you an example.
Does it
Say you have. I'm trying to find an example. Say you want to find, all the dogs, I guess, that are,
In this bed and the other bed, how many dogs?
dogs.
are there?
Say you have a you. Here, for example, say we have you in the system, right? And we know you are unique, right?
Right.
And we find another one of you, but it's a different one. There's two different Mendels in outer space,
Identity.
Right.
right? But it's the same one. Doesn't make any sense. They have the same hair color, same height, same anything. So we can know there's some issue up. We can handle it differently.
Oh, so if it equals, then automatically I can fix it.
Yeah, you can say we have an extra one here, or etc. We can do something with it. There's just
And when will it say it's not equal? If there's a small difference?
Yeah.
Another mender is gonna be bad.
Later on we'll learn more about in depth. We'll turn it off.
Because I'm saying, what happens if they're actually the same, but for some reason it...
Yes, it's up to you how to handle. Yes, later on. This is really just the introduction to that part. We'll discuss later on how more to handle it.